Hello, everyone. So today I'm going to talk about a project I have been working for the last few months, which is spaCy's rule-based lemmatizer. So, sorry. Back when I was in Argentina, I was doing an NLP course at university, and in this course we had to work mainly with text in Spanish. And the biggest problem that we had is that we couldn't find any good NLP libraries that had support for this language. So we were quite happy when we discovered spaCy, because it had support for Spanish, and it was performing really good for dependency parsing, part-of-speech tagging, tokenization, etc. But then we tried out the lemmatizer, and we were surprised to see that it was performing quite horribly. So, for example, if we took a text like this, which is just Wikipedia's description of Berlin, and lemmatized it with spaCy, we got the following lemmas, which are highlighted in gray. And if we take a closer look at them, we can see that half of them are wrong. So we wondered, why was this happening? Because the English lemmatizer was pretty good, pretty accurate. And we saw that the English lemmatizer was based on rules, while the Spanish version was only based on a lookup list. So in a lookup list, you have two columns in a table. And the first column just has a lot of inflected words. And in the other column, you have the corresponding lemmas. And what the lemmatizer does is just search for the correct lemma in that column. So in some cases, the lemmas were simply wrongly listed, but more interestingly, in some cases, the parts of speech were wrong. So some words, like these ones, are actually adverbs, determiners, and nouns, but the lookup lemmatizer was lemmatizing them as if they were verbs. So this is one of the downsides of lookup lists. They cannot lemmatize according to parts of speech. So if we have a word that has different parts of speech, it will always lemmatize it in the same way. And then we cannot handle out-of-vocabulary words. So if a word is not in the list, it will not lemmatize it. And these lists can never be exhaustive. So it would be really difficult, if not impossible, to list all the possible inflections in a language. So then, when I was doing this course, we tried some neural lemmatizers, and we were very happy with the results. Because these neural lemmatizers can handle out-of-vocabulary words. They are also language independent, which means that we can have the same system for a lot of different languages. And the good thing about them is that they're really good for languages such as Finnish, Turkish, or Hungarian, which have really, really rich morphology, and for which it would be really difficult to build lookup lists or rules. But the problem with these lemmatizers is that they are very, very slow. So this was OK for our little experiments in the NLP course, but the thing is that we couldn't use these for industry applications. So at the same time, I was also working for a chatbot company, and the most important thing for us was that we would reply the queries of clients in real time. And we ended up building our own lookup lists because we couldn't use these neural lemmatizers. So a few months later, I had the opportunity to come to Germany to study my master's. And I wanted to also have some experience in the industry, so I talked to Matt and Ines, and I proposed some ideas to work on spaCy. And especially, I wanted to work on the spaCy lemmatizer. So we decided to use a rule-based approach, because they can handle out-of-vocabulary words, they can lemmatize according to part of speech, and also by sets of morphological features, which is where I'm going to talk now. And they can have really good results for Romance and Germanic languages. And they are fast enough for industry applications. So spaCy has already an English lemmatizer. We wanted to just extend this idea to German, Spanish, and possibly other languages. But then we found some challenges, of course, because these languages have some particularities that English doesn't have. So first of all, I'm going to talk to you a little bit about the pipeline. So this is what we have now with the English lemmatizer. We have as input the word form and the part of speech. We then have a first step in which we preprocess. So we lowercase the words. In the case of Spanish, we also take out the accent marks, for example. We then check if lemmatization is actually needed, because there are some parts of speech for which we don't need lemmatization at all. For example, adverbs or determiners. Then we select the appropriate rules by part of speech. So we select specific rules if the word is a verb, or we select the specific rules for nouns if the word is a noun, etc. We then lemmatize, and finally, if we have more than one possibility, because sometimes we can have more than one possible lemma, more than one rule to apply, then we resort to a backup system, and we choose the most probable one. So for example, if we have the word marches, which is a verb, we first preprocess the word, which is lowercase it. Then we check if lemmatization is needed. So in this case, it is, because it is a verb. Then we search for the appropriate rules in the group of rules for verbs, and we find these two different rules, which say just take the last S, or just take out the last E and the last S. We apply them to the word form, and we come up with these two possible lemmas. And then finally, we have to resort to a backup system to choose the most probable one. And we output the lemma march. So something that we wanted to introduce in the new lemmatizer was universal dependency morphological features. Why we wanted this? Well, for English, we only have 21 rules in total. And when we key them by parts of speech, we have 8 rules for verbs, 4 rules for adjectives, and 9 rules for nouns. This means that in most of the cases, we won't have many rules to apply, and we will come up with only one possible lemma. We won't have to resort to any backup system. But with Spanish, we have 1,073 rules, and even when we key them by parts of speech, we come up with 1,061 rules for verbs, because verbs in Spanish have a lot of inflection. So we needed to somehow make these groups smaller, and we decided to use the morphological features for that. So in this way, we would have specific rules, for example, for verbs, which are in the past tense and the subjunctive mood, and that are in first person plural. And then we have these smaller groups. And the same with other languages. For example, for German. So German doesn't have that much inflection with verbs, but it does with adjectives and nouns, because we have all these cases, nominative, dative, accusative, etc. So the idea is that we could take a text and, first of all, predict the parts of speech of each word and their morphological features. And then we could feed the lemmatizer with, first, the word form itself, the part of speech, and the set of morphological features. And in this way, we can select a smaller group of rules. So we tested this with the universal dependency corpora for Spanish, and we got only 0.32% of ambiguous lemmas. That is, one word form that had more than one lemma. And these are the only cases where we have to resort to a backup system, which is good enough for us. Then another thing that we wanted to introduce was the possibility to apply subsequent rules to the same string. So in English, we have irregular verbs, and right now the rule-based lemmatizer deals with these cases by searching in a lookup list with exceptions, all the irregular verbs in English. And then if the verbs are not irregular, we just apply their rules. But with Spanish, we couldn't find, of course, an exception list. We didn't have this resource available. So we had to think of another way of handling with irregular verbs. And we thought, okay, actually verbs in Spanish mainly also follow certain patterns. So we can apply rules for these too. So for example, if we have the word form recuerdo in Spanish, we first apply the rule that applies to all the regular verbs, which says just take out the last O and add AR at the end. And we come with the lemma recuerdar, which is not correct. So we have to apply a second rule, which changes the vowels in the middle, and then we can finally come up with the correct lemma. And the same with German. So we have some irregular participles in German, like gemacht. First, we apply the rules for all the participles, which says just take the prefix ge out, and we come up with macht. But then this is not the correct lemma. We have to also apply a second rule that changes the last T by en. And we come up with the lemma machen. And finally, something that we wanted to keep in mind while building the lemmatizer was to do it in a modular design. So we want to have a common lemmatizer for all the languages with the main pipeline and all the main functions. And then we want to have special modules with only those functions that have to be different for each language. And then we can increasingly add new languages in an easier way. So some of the specific functions for the language modules are, for example, preprocessing. So in English, we only have to lowercase, but in Spanish, we also have to handle accent marks. In German, we have to handle umlauts, etc. Then, as I said, for English, we just have an exception list with all the irregular verbs. And in Spanish, we handle it with rules. Then in English, there are certain parts of speech which do not need lemmatization, like determiners, adjectives, and male singular nouns. But all of these are actually inflected in Spanish. So this list of non-lemmatized words will be different, non-lemmatized parts of speech or morphological features. And another thing that has to change according to the language is whether or not we apply subsequent rules. So in English, we do not need it, but in Spanish, German, and other languages, it is a useful thing to have. And of course, all the rules are going to be different for each language, and also the sets of morphological features, the groups of rules. So we tested our lemmatizer, and first we used the gold morphological features and parts of speech annotated by hand, which we got from the universal dependency data, and we got 99.37% of accuracy. But then we wanted to have a little bit more realistic number, because in real life, we will have to predict the parts of speech and the morphological features. So we used the Stanford neural system, which was developed for the CONLL shared task 2018, and we got 98.14% of accuracy. And finally, we also used the Stanford neural system to lemmatize, and we got 98.11% of accuracy. And as we can see, our system is on par with that neural approach, but it's a lot faster and more appropriate for industry. So in conclusion, the things that we added, that we introduced in this new lemmatizer are more fine-grained rules, which are keyed by parts of speech and also by sets of morphological features. And they are in the universal dependency format because we want to keep this universal mindset. We do not want to change so many things when we build the lemmatizers for the different languages. So we prefer to use this common format. And then subsequent rules can be applied, as I explained before. And now we have this more modular design in which it is easier to add more languages. So in the near future, we will be happy to introduce this new, more accurate, simple, and fast lemmatizer for Spanish, then German, and potentially other languages. So thank you for listening.